In the last video, we saw that elimination reactions can proceed through two different mechanisms, an E1 or an E2 pathway. In this video, we'll look at the reaction features that determine which pathway the reaction will favor. And there are four key features for us to consider: the electrophile, the base, the leaving group, and the solvent. And we'll look at one at a time. First, let's consider the electrophile. Both E1 and E2 reactions favor more substituted electrophiles. So tertiary alkyl halides will be more reactive in both E1 and E2 reactions than secondary alkyl halides, which will be more reactive than primary alkyl halides. This occurs for two different reasons. In E1 reactions, the more substituted alkyl halide generates the more stable carbocation intermediate. In E2 reactions, the more substituted alkyl halide generates the more stable alkene product. So E1 and E2 reactions favor more substituted alkyl halides for different reasons. But in both cases, elimination from the more substituted starting materials will be more favorable than their less substituted counterparts. Now let's consider the base. Remember that an E1 reaction begins with the base deprotonating the beta hydrogen. But in an E2 reaction, the base doesn't factor into the first reaction step, or the slow step. That means that E2 reactions will require a strong base in order to initiate the reaction by deprotonation. But E1 reactions don't depend on the base, and so with weak bases, E1 reactions will be favored. And here I've just categorized some common bases as strong or weak. And it's important to remember that bases and nucleophiles are very similar, and often a good base is also a good nucleophile. So here I've also included the relative nucleophilicity of these reactants, and this will be important for thinking about the likelihood of a substitution versus an elimination reaction. Just focusing on elimination reactions here, in general, the strong bases will favor E2 reactions, while the weak bases that are not very nucleophilic will favor E1 reactions. Weak bases that are good nucleophiles will favor substitution reactions. The third factor to consider is the leaving group. Good leaving groups will accelerate both E1 and E2 reactions, but E1 reactions, which begin with the loss of the leaving group, must have a good leaving group. So while both reactions favor good leaving groups, it is a requirement to have a good leaving group for an E1 reaction. And on this slide, the rankings of leaving groups is exactly what we saw with our substitution reactions. Finally, we'll consider the solvent. And remember that for SN1 and SN2 reactions, we saw the differences between polar protic and aprotic solvents. For elimination reactions, the different solvents favor different pathways. In an elimination reaction, protic solvents will stabilize the base, and because the base is important to E2 reactions, the base initiates the E2 reaction. Using a protic solvent will slow down or disfavor an E2 reaction. And so instead, E2 reactions are preferred in polar aprotic solvents. In an E1 reaction, the protic solvent stabilizes cationic intermediates and transition states, and so protic solvents will favor E1 pathways. We'll end this lecture video with the question we saw at the beginning, to predict the product of the elimination reaction shown. We'll start by identifying the leaving group and the beta hydrogen. Then we'll determine if this is an E1 or an E2 pathway by looking at the reaction conditions. Here we have two different hydrogens that could be deprotonated. But looking at our reaction conditions, we have a tertiary alkyl halide, which is prone to forming the carbocation. And the reaction is run in a polar protic solvent. So this reaction will favor an E1 pathway. The E1 pathway proceeds through the carbocation intermediate and will form the more substituted product in preference over the less substituted product.